Get the lights, please.
He gets fraternized.
Fraternizing.
It just sounds good.
Yeah, it's a funny one. Yeah, I was sitting with her in the cafeteria just a few minutes ago, and I told her that that it was my treat. So don't try to do anything stupid. I used some other words than that, but um, then she started arguing with me. I said, "Fine, you pay for the whole thing then." Even my, so I think I'm getting free Thanksgiving. Like, hey, that's what you get. You got to train people. You're going to be stubborn when somebody tries to give you a gift, and you get stubborn about it. Now it's a free meal. That's what is what it is. I'm just gonna, as soon as it gets there tomorrow, I'm just gonna slide it over to her side of the table. $50 a person. Be $200 plus tax plus tip. It's Thanksgiving. You can't give them a crappy tip. So that's probably a $40 tip. So that's gonna be a $250, $260 bill. All on a part-time lunch lady salary.
I went out to eat one for like a lot of hundreds, where someone was paying and it was like an $800 bill.
Yeah.
Like, one person paid it.
Well, how many people?
There was like 8 of us.
Okay.
Actually, maybe like
So it's still a pretty nice place. I mean, each dinner was $50, $60, and then there was probably some wine around or something like that. Yeah. What was I doing? Oh, talking about authentication, right? So right now we have we were doing some crazy animation stuff at the end of class last time. Yeah, we wanted to make it do a little more cool awesomeness though.
Oh yeah, we didn't get the timing now.
Yeah, let's look at that for a second. So we had to be doing something stupid. Um, so in view did load, we're setting the frame so it's off the screen. Just for right now, I want to set it so, just comment that line out. Let's just get it in the upper left-hand corner and see what that looks like. Okay, so that's at 0, 0. So what we want to do is we want to have over some number of seconds it go up. So we can see the little the dude dangling over here. So let's try just doing that part. So I'm going to steal this line. And we'll do UI view animation. Let's just do the with duration. And let's say over 3.0 seconds. And let's take it to minus 200. So this should say after the view did load, we start the guy off at 0, 0, upper left-hand corner. Then let's move it to 0 on the X, negative 200 on the Y, so that should shift it up over 3 seconds. Okay? See, that's interesting. Why isn't it well, I just moved it to negative 200, so that's X is 0, Y is negative, let's do negative 500. That should be way off the screen. Yeah, see, that seems to be the problem. Is this guy is not shifted to the right. Okay, well, he's not moving at all, which tells me, did we not hook it up? I think we hooked it up because we've seen a little bit of animation working. Yeah, there's our puppet image. Let's hook it up again. All right, he's movable. Let's try something here. All right, I'm going to go ahead and add it as a sub view in view did load. I wonder if maybe there's something going on with how we were putting it in there. All right, so we'll say self.view add subview puppet image. And before we do that, let's go ahead and set the rect for that guy at 100 to the right and 200 up. So it should look pretty off center. And it should also cover everything. Okay, good. Now, after we add it as a subview, we want to say self.view send subview to back puppet image. That way it's behind everything. So we're just programmatically moving that guy behind all the other layers. Okay. So now let's start off at 0, 0. Oh, actually, I think I know what the problem is. Didn't we still have that auto layout on? Yeah, let's try this. That could be the issue. So this over 3 seconds should make it go up. Okay, perfect. So now let's have it go over 1 second. We'll have it go to negative 200. And then completion. Let's have it go back to 0, 0. Screw something up there. We just steal this. UI view animate. There was one that said automatically.
I think it was auto layout. Mine looked like it worked.
Okay. All right. Well, so this is how you bypass the auto layout thing. We'll do 1.5 seconds. void that guy, completion that guy, get rid of this. So the first time we'll move it to 0, -200. Second time we'll move it to 0, 0. Animations. Oh, bool finished. That's the problem. So now this should go up, then back down. That's no fun. We just jump back down. We need to put a second animation in there to make it go back down. Let's do this. And no completion on this one. Okay, so for our first animation, do that. On completion, we're going to do a UI view, animate with duration, all this crap. Close it, close that. Close that, semicolon. Right? So now it should go up, then back down. Legit enough?
Now down to that 199.
Huh?
199.
Yeah, we're at $1.99. If we wanted to just keep going, we would just keep calling methods that would do the animations. That make sense?
How much would that kill battery life?
Well, it would only exist when you're on this screen.
I feel like you'd be done.
So what I would do is I would do this. I would have, I would write a couple of methods. Void animate up. And then I'd have a second one called animate down. And then for animate up, I would do, let me just steal all this code. I would make it go up over 1.5 seconds. And then on completion, I would call self animate down. And then I would have animate down over 1.5 seconds, take it back to 0, 0, And on completion, call animate up. So then in here, I would say self animate up to get the ball rolling. And just for completeness, even though we don't need it, I'm going to go ahead and define these in the .h file. Okay, so inside of viewDidLoad, what do we do? viewDidLoad, we're going to go ahead and add the guy as a subview because that bypasses our auto layout thing. So we just bypassed Apple's thing to make things look pretty right off the bat by adding it at runtime. And then what do? We call animate up to get the ball rolling. What does animate up do? It, over 1.5 seconds, makes the guy go up. Then, when that's done, it calls animate down. Animate down says over 1.5 seconds, make the guy go back down. When it's done, call animate up. So we built a loop into the two of them. That make sense? So now we should have our Puppet Master going pretty good here. Now we need to add a cackling noise. pretty legit. That actually kind of looks like really cool. You can actually see it because we made the password box kind of translucent. Okay, so now, now that we have the zip file done correctly, let's talk about our how username and password will actually work. So let's actually talk about authentication. And we want to think about doing this in terms of parse. But for authentication, we really have two choices. Choice number one, read in a username and password and send them to the server to validate. Choice number two, read in a username and password and ask the server for the necessary info to validate. So now we're using parse. So what we're going to do is inside parse, we're probably going to create a user object. And a user object is going to have a username and a password. Okay? And that username and a password is going to be, we'll probably hard code a couple in initially. So let's actually go and do that. So we need to go over to our dashboard, go to our data browser. We'll create a new class. I actually think it has a built-in thing for user authentication, but we're going to not use that. We'll use our own. Let's call this guy an authentication object. So we'll create that class. All right. So now we need to add some stuff. So by default, we have an object ID, a created at, an updated at. So what I want to do is I'm going to add a column. Column type is going to be a string. And we'll call this guy username. We'll add another column. Column type will also be a string. And we'll call this password. Okay? Isn't that interesting how it puts the second one there at the very end? Huh? Well, why does it put it to the very end? Like, why does it do the first one, like, beautifully perfect? Everybody relax. That was magic. And then the second one just throws at the end.
Because logic.
There's no logic in this place. Okay. So, let's go ahead and add a row. So I'm not going to put anything for the object ID. Let that go ahead and assign one for me. So we're going to create a username, AwesomeFat. And we're going to have a password. Let's see. Password is blah. Okay. And there's our object. Okay. So we have a couple of options. Well, the first thing we can do, let's do this the simple way first and then see what's wrong with it. As usual. Okay, so I think right now all of our parse stuff is inside of our manage roles, correct? Here, let me just steal this code. That'll give us enough to work off of here. Go back to our login.m. And we want to go ahead, I'll actually go to login.h first. We want to create a IB action for our login button. So that something happens when we click that login button pressed. And let's go ahead and implement it here. And I'll paste my code in. We're going to need to import parse.h. Okay, so we want to query from our authentication object where what? Let's say where username matches something, and well, here I'm just going to actually steal this line, and password matches something. Now, what are those somethings? Those somethings should be our two text fields, the username and password we entered, correct? Okay, so let me go ahead. Let's create a couple of IB outlets. Oh, we already have them. Username TF and password TF. So we're going to pass this guy username tf.text, and we'll pass this guy password tf.text. All right. Then we'll actually execute our query. Actually, let's do it this way. So we'll say if query count objects is equal to 0, meaning we didn't get any objects, then we're going to say UI alert view pointer AV is equal to a UI alert view alloc init with title, let's say login error, message, bad username / password, delegate, we'll say nil because we're not going to respond to it. Cancel button is okay. Oop. And no other buttons. And then we'll say AV show. So if we didn't get anybody logged in, then we want to yell at them saying bad username and password. Otherwise, for right now, let's say PF object pointer the user is equal to query get first object. We should only have one, right? Let's just assume we can only have one now. Okay. We're going to make the assumption that we're not going to let two people have the same username and password combination. I think that's a reasonable enough assumption for this example. So we'll go ahead and get the first object because there should only be one object. And then we'll do nslog the user value for key object ID. And print that out. So the idea is if this works, we should display to the screen this crazy looking jumbled number here, or number string, very few numbers in there actually. This jumbled thing. Okay. So if we did find somebody who had the same username we entered in and the same password we entered in, then we're going to spit out to the nslog this random string, which is a way to uniquely identify a user in the database. That make sense? Otherwise, we're going to give them a pop-up saying bad username and password. Let them try again. Okay. So go ahead and save that. We'll run. So I'm just going to go ahead and type in some bad stuff. Oh, I don't actually even have a login button. What is Simon writing this code? All right, we need to give ourselves a login button. Didn't somebody last time say, don't we need a button? The answer is yes, we need a button. All right, so let's make this a grayish color, and then also make this a more better font. All right, perfect. And then lastly, we need to hook up that IB action to that guy. So here's our login button pressed. We'll do that on touchdown. Okay, so now we'll run this. And that Puppet Master hand's kind of distracting in the background. So I don't know if I want to use this app. So here, we'll randomly type in some stuff. Obviously a bad username and password, right? We'll click login, try to hit the database. Bad username / password. Okay, let's try again. We probably could have been nice and zeroed out our fields, but we didn't. I think I entered in the correct username and password this time. Okay, I did. So notice that we got our random string. Make sense? So we just did a type of authentication. Make sense? So in this case, if we go back to our options, one of our choices was to read in a username and password, which we did, and then send them to the server to validate. So I would have sent out my username, sent out my password to the server, and have the server then validate it for me. That make sense? Or I could ask the server to send me all the information I needed to validate myself. Which did we do? We had the server validate it by doing the query, right? So we said, server, give me all of the user object or authentication objects that you have that match a username of this and a password of this. So then he handed me either nothing, a query with no elements in it, or we assumed one element in it. Make sense? So we had the server actually do the validation. How could we have done the validation ourselves? What if we wanted to do it locally? How would we have done it differently?
Do it the other way or do it
Well, do it the other way. So we did choice one. Let's say we don't like choice one, we want to do choice two. So we're going to say choice one is a no-go, even though we just saw it work. So now when you hit the login button, we actually want to use, so here I'll comment this out for right now. This is choice one. And I'll wrap that in comment stuff. So now we want to implement choice two. Pull off the exact same logic, but do it the other way. That is, the way that says, we're going to read in a username and password and ask the server for all the information we need in order to validate that username and password. So what will we do for that one? I'll steal this code as a starting point. Still going to create a query, right? Around authentication objects. Then we're going to create an NS array called the AOs, the authentication objects. And this guy will be query. We have a find objects. Okay, so this is going to give us a full array of all of the authentication objects that live there. Then we're going to say for PF object pointer in the AOs if username tf.text is equal to string. Oh, I need to give myself a name, a variable name for that PF object, so we'll call it AO, is equal to AO value for key username. If that's true, I probably need to spell username a little bit more better than that. Swing back around there for, and so let's go ahead and fix our password text field is equal to the value of our password for this particular AO. If both of those things are true, then what do we want to do? We want to output AO value for object or value for key object ID. And then we want to break out of our loop. We don't want to check anymore. We found the guy. That makes sense? But now we need to be able to handle not finding the guy. So before this, we'll go ahead and say bool found is equal to no. We have not found the guy we're looking for yet. No is like saying false. So in Objective-C, true false is actually yes, no. So before we break out, we're going to set found equal to yes. So I found a match where the username and password are equal to the current PF object I'm looking at. So I'll output the crazy object ID, switch my found variable to yes, that I did find them, and then break out of this loop. After that loop's done, we'll ask if not found. That means if found is equal to false, which means that it started off at no, and I never changed it to yes. So if found is still false, then what am I going to do? I'm going to show my UI alert view. Make sense? So this is how we could implement choice 2. Let's go ahead and run this, make sure it's equivalent. I'll put in random crap, bad username password. I'll put in the correct information, and we get our random string. Okay? Which is better in this case, choice 1 or choice 2, and why? I'll leave that code up in case somebody's copying it. The starting point is that they're actually both inadequate from a security perspective. But one of them is clearly the better choice between the two. Which one is it and why? Is better?
Yeah.
Why?
You don't have to transfer potentially sensitive data across just still having to do that. Second of all, use by escalation.
Okay, well, but let's go back. We do still have to transfer potentially sensitive data. Even in the first one, I'm still receiving the PF object for that particular user, right? So I'm still getting an object that has a username and a password in it.
But less.
Yeah, I'm receiving one of those instead of number of users on system, right? So if let's say this was eBay. How many users do you think eBay has? A lot of users, right? Millions of users. They probably eBay probably has multiple millions of unique accounts. Be my guess. I mean, anybody have a major problem with that statement? Okay, so that means that when I did this query, this one right here, I'm saying, give me all of those 5 million accounts, and then I will sift through them on my own and see if I find a match. Make sense? So you got your little iPhone there looking through 5 million accounts saying, does the username and password match this guy? No. Does the username and password match this guy? No. Does the username and password match this guy? Where in the first one, what did we do? We sent up the username and password to the cloud and said, send me either 0 or send me at most one account that matches these credentials. We don't care what they're doing up there in order to do that. Chances are they're using some sort of, fast search algorithm with their database or data store or something like that for finding stuff quickly, but it's not our problem. Is the punchline, right? Find it however you're going to find it. We have the power with parse to basically create queries. Give me only the guy I'm looking for, or don't give me anything. Make sense? So the first one out of these two is better because it's substantially more efficient. We can automatically start off and say, we are probably not going to write code that's more efficient than what they're doing up there, because we trust our cloud service provider more than we maybe trust ourselves for this type of thing. If you don't, then you might consider switching to a different cloud service provider. So we're going to say they know how to store crap, And they probably then also know how to query it quickly. So kind of the requirements for database stuff. So we're going to say we enjoy the service that they have by storing our stuff in the cloud, and we will rely on them to search it for us quickly, rather than us searching through the stuff ourselves. So option number 1 in this case is the better option. And as Coleslaw pointed out, is also less code.
Like to complain about this, what happened? Well, it takes 5 hours to log in.
Well, it's eBay. There's a lot of users.
I have to wake up at 3 in the morning to start my login process.
Start my life. Every day you set your alarm. My wife actually does that. Not at 3 in the morning, but when my wife wakes up in the morning, she works remotely for Western Illinois University. That's where I used to teach, and she's a programmer for them. She used to work in an office there, but then when we moved up here, she kept her job and now works from the house. But remotes into a mainframe there and writes COBOL software. Well, she wouldn't have to do this but it's a Windows machine. It takes a while to boot up because it has all these login things that, like virus scans and all this crap. So like she'll wake up and she has to be at work at 8, but she'll go up there at 7 before she feeds the cats and all that stuff. And begin the login process so that when she shows up to work at 8, her machine is ready to go. It's finished cooking. So every morning she's basically, doing a Windows 7 roast. All right, so now, do we understand these two things? What we've done? So we have an authentication process now, right? The reality is now that we have our authentication process, what do we want to do? We're probably going to show our main VC, correct? So we're going to go ahead and we're going to import main vc.h. And here, I'll comment out choice 2, because actually it was noticeably slower, wasn't it? Even though we only had 1 record come back. And we'll uncomment out choice 1. And then rather than outputting the object ID, we'll put a comment on that so we can grab that line again later. Both these lines, actually. We'll go ahead and we'll say self.navigation controller, push view controller, main VC, alloc, init, animated, yes. So now when we successfully log in, it'll take us to our old main home screen. Okay, so we logged into our app. So now, what's wrong with both of these? This goes back to what Coleslaw was saying about sensitive data. We all have passwords. So just think about human being password behavior. All of us in here, I would guess, probably have 2 or 3 passwords that we use for everything. Pretty safe bet, right? We have that one password that we use for important stuff. And we have another password that we use for kind of the medium stuff. And then we have the third password that we use for those stupid sites that have the weird rules for your passwords. They have to have an uppercase letter and a couple extra numbers, all that stuff, right? That's not that, I'm sure that's not that far off from what we all do. It's somewhere in the right ballpark, right? So the idea is, except now our operating systems are trying to go away from this, at least Mavericks, for every single time I go to a web page with Safari that has a username and password, Mavericks, they store your keychain for you. So they want to suggest, a 256 character password for me to store. And they say, we'll remember this for you, don't worry about it. It's like, look, I've had some good experience with iCloud, and it hasn't all been good. But in any case, it's, yeah.
Okay, so what's your old password? Crap.
Nobody knows that. Nobody has the patience to type that. But it would make it pretty secure. But in any case, so let's say you have your any one of your passwords. All of our passwords are important, even if it's for our stupid little things, right? Maybe you have that one public password that you set stuff to, like, because it's easy for you to type, and you say, look, if you've got to give a friend one of your passwords, you change it to that one. Give them the one that you don't care if people know. And then you change it back to something secure once they're done doing whatever they're doing. Huh? Right. Exactly. Well, so in any case, the issue we have here is we are sending passwords, plain text. So I'm sending my password. I type in my password in our field, blah. I'm sending it to the cloud, whether I'm using choice 1 or choice 2. I'm sending my plain text password up there. I'm saying, here you go. Here's my password. It's getting sent through the air magically between me and the cloud. Somebody else could be sniffing the network or something and pull my password out of there. No problem. Similarly, when I pull the data from the cloud, now I'm pulling in 5 million people's passwords. Like, well, let me just look through these. So anytime we're storing passwords, we probably don't want to store them in plain text. Correct? I want to store them somewhat securely. We probably even care more about credit cards. Right? You know, you don't buy something online unless you see the little lock and key thing on the bottom. How many of you actually look for that anymore? We just kind of assume it's there, right? Any store you go to, like, oh, well, this place seems legit. I'm sure it's secure. we don't even know. And what does secure mean? What does a little lock mean? I mean, heck, I got a bug on my iPhone that sometimes my alarm goes off when it says it's not on. How do I know the lock means anything? So, in any case, we need to have an alternative solution for authentication so that we're not sending plain text information. So what we're going to do, start with next time, and we're going to do a simple little encryption that we did in the 250 class. We'll do ROT13. It's not secure encryption, but we'll understand the premise here. We're going to encrypt it locally. And whenever we store it, we'll also store it encrypted. So when we read in the password blah, we'll encrypt it and compare the encrypted version to the encrypted version. Does that make sense? If your password encrypted matches the stored password that's also encrypted, you must have typed the password in right, even though we never actually had to send what your actual password was. We just sent the encrypted version of it. That make sense? Go ahead.
Will you send it back encrypted to you?
We don't need the password. They don't. The bottom line, yeah, we could. Yeah, we could. But the bottom line is right now we're having it send to the entire object. But I mean, we don't even need the password again. Password just gets us through the door. Then you don't need that password. But we would send it back encrypted in this case since we're getting it in an object. So we're never actually transmitting a plain text version of the password. Make sense? All right. So everybody have a happy and safe Thanksgiving, and I'll see everybody next Monday.